Hello viewers, I'm Kausalya. Today we are going to see an introduction about RLC series circuit. So here, as the name mentioned, it is a series circuit. Here we are having R, L and C connected in series. Here V is the source voltage or supply voltage and I is the current that flows through the circuit. And VR, VL and VC are the respective voltage drop across resistors, inductors and capacitors. Right. So now again here we are going to draw phasor diagram to show the relationship between voltage and current for individual parameters. That is, first we are going to consider resistors, next we are going to consider inductors and finally here we are going to consider capacitors. And we are going to draw how the voltage and current relationship in these elements, right? So as we all know, you see, this is in a resistor, this is in an inductor and this condition is in a capacitor, right? So this is a pure resistor circuit, therefore voltage and current are in phase. So here this is a pure inductive circuit. Therefore what happens? The current lags the voltage by 90 degrees. Here it is a pure capacitive circuit. So here what happens? The current leads the voltage by 90 degrees. Right. And as we all know, voltage across resistor is given by the formula I into R. And here voltage across inductor is given by I into XL and voltage across capacitor is given by I into XC. Right. Here as we have all the three elements, we are going to make an assumption to draw the phasor diagram. Right. So here we are assuming XL is greater than XC and VL is greater than VC. Right. Now here again I is taken as reference. Why I is taken as reference here? Because in series circuits I remains common in all the three elements. Okay. That is the same current flows through all the elements. So here I is taken as reference here. Right. So in a resistive circuit, I, that is V and I are in phase. Therefore VR and I are together here. Right. And inductive circuit, as we all know, here what to say? Voltage leads the current by 90 degrees. So this is your VL. So voltage leads the current by 90 degrees. Whereas in case of capacitive circuits, that is in case of capacitor, what happens? Again, the voltage lags the current by 90 degrees. Right. So now we have drawn VR, VL and VC. How to calculate the total voltage here? So this VC, just assume that we are folding this VC and placing over the same line. Okay. So what happens? That is addition of all these voltages will give you the total voltage V. Right. So when you add this VC over here, that is VL and VC are exactly opposite to each other. Therefore, the difference comes into picture here. Right. For example, consider this VL as sum 9 and this VC as sum 4. Okay. Then what happens? VL minus VC, that is 9 minus 4, that will give the value as 5 here. Right. So for example, here 5 and here we are having sum 4. So what will be your V? V is nothing but V square is nothing but 5 square plus 4 square. Right. In the same way, you see, this V square is nothing but VR square plus VL minus VC the whole square. Right. Now VR, VL, VC, we know the formula. So just substitute that. Then in all these expressions, you see I square is common, right? So we are taking I square outside. So the remaining terms will be, here we will be having R square and here we will be having XL minus XC the whole square, right? Again, when you take square root on both sides, here we will be having V and here it is I and here it will become square root of R square plus XL minus XC the whole square. Right. And when you move this V downwards, it becomes V by I. So V by I is nothing but our impedance Z. Right. So again, XL minus XC, we are replacing it with a single X. Therefore, impedance in an RLC series circuit is square root of R square plus X square. Here X is nothing but XL minus XC. Right. So here there are three cases to be considered. So what are all those? You see, when XL is greater than XC, right? Then the circuit is said to be RL circuit. Okay, the circuit behaves as a RL circuit. So in an RL circuit, what happens? I lags behind the voltage, right? Current lags behind the voltage. Therefore, the power factor is a lagging one. In case 2, when XL is less than XC, what happens? The circuit behaves as an RC circuit. Therefore, here current leads the supply voltage, right? Therefore, the power factor is leading. In some cases, when XL is equal to XC, the circuit is said to be purely resistive. Therefore, I is in phase with the voltage, and here in this case, the power factor is said to be unity, right? So here we are drawing impedance triangle. So when XL is greater than XC, right? So this inductive part becomes dominant here. Therefore, our impedance triangle comes like this. This is your R, this is your XL minus XC. And when you combine these two things, you are getting impedance Z, right? Similarly here, this is your R. And here what happens? XC is greater than XL. So only this impedance triangle is in the form that is reversed, right? So here this is XC minus XL, and here this total value is Z here, right? Now you see, V is nothing but the source voltage. It is Vm into sine omega t, and pi is the phase angle, right? So we are going to write expressions for I. So I is nothing but Im into sine omega t minus pi in the case of XL greater than XC. And here it is I equal to Im sine of omega t plus pi when XL is less than XC or XC is greater than XL, right? And here when XL is equal to XC, our expression is I is equal to Im into sine omega t, right? So the next thing is the impedance for RLC series circuit in complex form. That is, complex form is nothing but rectangular form. So it is generally represented as Z is equal to R plus J into XL minus XC, right? So here comes the end of our derivation. Here in this case, we are having three elements which are connected in series, right? So even though we are having these three elements, the circuit can either behave as a RL circuit or an RC circuit or a purely resistive circuit, right? The dominant factor plays a main role. That is, when inductance is more predominant, then it acts as an RL circuit. When capacitance is more predominant, it acts as an RC circuit. When both the value of XL and XC are equal, then it acts as a resistive circuit, right? So keep these things in your mind. If you have any doubt, let me know in the comment section. Thank you.